Okay, you can use this video to help you with your corrections on your Unit 4 test, which is on absolute value equations and inequalities. Feel free to fast forward to what you need to watch. You can rewind it as many times as you want to see questions over again that you might have trouble with. We're going to go ahead and start with number 1. Anytime we have an absolute value equation, we're going to solve that absolute value equation by isolating the absolute value. So we're going to start by dividing both sides by 3. So we'll have the absolute value of 2y minus 5 is equal to 9, which means that 2y minus 5 is either equal to 9 or 2y minus 5, which is in the absolute value, is equal to negative 9. And if I solve both sides of this equation, I'll start by adding 5 to both sides here. So on the first equation, I'll have 2y equals 14. If I divide by 2, y is equal to 7. On the other side of the equation, if I add 5 to both sides, I'll have 2y equals negative 9 plus 5, which is negative 4. And then when I divide both sides by 2, I'll get that y equals negative 2. There won't be any extraneous solutions on this problem because the only variable is inside the absolute value. So our two solutions are y equals 7 and y equals negative 2. Same kind of thing in number 2, except the only difference is in number 2 we have 2 variables. We'll start the same way though. Either the absolute value of x plus 5, or I should just say x plus 5, which is the absolute value, is either equal to 2x minus 3, or x plus 5 is equal to negative 2x plus 3. So we're going to solve both of those equations then. To solve the first equation, I could subtract an x from both sides. So I'll have x. I can also add 3 to both sides. So 5 plus 3 would be equal to 8, and the negative 3 plus 3 cancel each other out. So one solution is that x equals 8. For my other solution, I'm going to add 2x to both sides, which means I'm going to have x plus 2x, which is 3x. I can also subtract 5 from both sides. So I'll have a positive 3 minus 5, which is negative 2. And if I divide both sides by 3, x will equal negative 2/3. But because I have an absolute value both inside and outside of the absolute value sign, or a variable both inside and outside of the absolute value sign, I'd have to check for extraneous solutions. The first one, 8, if I plug an 8 in for x, 8 plus 5 is 13, and the absolute value of 13 is 13. So that is the left side, and on the right side, 2 times 8 is 16, and 16 minus 3 is 13. So this one checks out. But when I plug in negative 2/3, if I just plug it into the right side of the equation, we would see that 2 times negative 2/3, which is negative 4/3, minus 3. Well, 3 is the same thing as 9/3. So if I have negative 4/3 minus 9/3, that's negative 13/3. That's a negative number. And we can't have an absolute value equal a negative number. So this doesn't work. That's an extraneous solution. And the only real solution that we have is x equals 8. We move on to number 3. I'm going to start by adding 2x to both sides. So I'll have the absolute value of 3x plus 5 is equal to 5x plus 4. And then when I write my 2 separate equations, I'll have 3x plus 5 really does equal 5x plus 4. Or I have 3x plus 5 equals negative 5x minus 4. And if I solve the first equation, I will subtract 3x from both sides. So here I'll have 2x. I can also subtract 4 from both sides. So 5 minus 4 will equal 1. And if I divide both sides by 2, x equals a half. Well, then when I solve the other side, if I add 5x to both sides, here, I'm going to have 8x. This will be gone. If I subtract 5 from both sides, then negative 4 minus 5 is negative 9. And when I divide by 8, x is negative 9/8. But again, I could have an extraneous solution here. So what I'm going to want to do is plug in 1/2. And I'd probably plug in 1/2 into this equation here just because it'd be easier to work out. If I plug 1/2 in here, 3 times 1/2 is 1.5, and 1.5 plus 5 is 6.5. And then when I plug 1/2 in here, 5 times 1/2 is 2.5, and 2.5 plus 4 is also 6.5. So this checks out as being a real solution. But then over here, when I plug in -9/8, well, I can multiply, if I just plug it into the right side of this equation, 5 times -9/8 is -45/8 plus 4. Well, 4 is the same thing as 32/8. I'm going to get -13/8. And again, just like in number 2, I can't have an absolute value equation or an absolute value equal a negative number, which is what I would have there. This then is an extraneous solution. And the only solution there is that x equals 1/2. Okay, then 4 through 6, we're solving an absolute value inequality and then graphing the solution. So what I would do for number 4 to start off with is I would subtract 7 from both sides, and I'd have the absolute value of 3x minus 2 is greater than or equal to 4. Because it's greater than or equal to, I'm going to have two equations. 3x minus 2 is greater than or equal to 4, and those two equations are going to be separated with an or sign, an or between them. So the other equation is going to be 3x minus 2 is less than or equal to -4. Solving the first one, I will add 2 to both sides, so 3x is greater than or equal to 6, and dividing by 3, x is greater than or equal to 2. Or, if I solve the other side, if I add 2 to both sides, I'll have 3x is less than or equal to -2. If I divide by 3, I'll have x is less than or equal to -2/3. So this is my solution, but then to graph my solution, I'd have a point at 2 and a point at -2/3. Both are going to be closed circles. It's greater than or equal to 2, and it's less than or equal to -2/3. So it would be a graph that looks something like this. Moving on to number 5. Again, I want to isolate the absolute value. So the first thing I would do is add 5 to both sides. So now I have 4 times the absolute value of 2x minus 1 is less than or equal to 12. Then if I divide both sides by 4, I would have the absolute value of 2x minus 1 is less than or equal to 3. Now I have an isolated absolute value sign. It is less than, and I'm going to write it like this. 2x minus 1 really is less than or equal to 3, and it's greater than or equal to -3. So it's a compound inequality with an and, which I can write as a 3-sided inequality. So then I'm going to add 1 to all 3 sides. So I'd have -2 is less than or equal to 2x, which is less than or equal to 4. And if I divide by 2, I'd have -1 is less than or equal to x, which is less than or equal to 2. And graphing this, I'd have points at -1 and 2, closed circles at both of them. And I'm going to shade everything in between them because it is less than 2 and greater than -1. Number 6. 6 is an unusual equation, but we had a couple starter problems similar to this the last few days. If I divide both sides by -3 to isolate the absolute value, I'm going to have the absolute value of 2m minus 8. I'm going to switch the sign because I'm dividing by a negative number, and 6 divided by -3 is -2. So if we think about this, we're looking for a distance, an absolute value that is less than -2. Well, we know that every absolute value ends up being a positive number, and there isn't a positive number that is less than -2. So number 6 is simply no solution. Let's go ahead and look at the second page. Second page, starting with number 7, says write the following tolerance situation as an absolute value inequality, a simplified compound inequality, and then graph each situation. It's 5 points for each part, 2, 2, and 1. So the absolute value equation for the first one, we're looking for the length of a windshield that should be 48.25 inches, give or take 0.12 inches. So this is going to look something like this. X minus 48.25, that is the mean or the middle number, the number that we're shooting for, is less than or equal to the tolerance, which in this case is 0.12. That's what the absolute value inequality would look like. We could write this like this. X minus 48.25 really is less than or equal to 0.12, and it's greater than or equal to negative 0.12. Well, then if I add 48.25 to both sides, the number in the middle, or the variable, is going to be by itself in the middle. And if I take 0.12 plus 48.25, I'm going to have 48.37. And then if I add 48.25 to negative 0.12, I'm going to have 48.13. I think I did that right. So that would be the range in the graph. We have 48.13 and 48.37. Close circles at both, and we would accept anything in the middle, even though we'd really be shooting for exactly 48.25. Number 8 is a very similar equation, except they give us a little bit different information. It says the length of a football should be anything between and including 14.25 and 14.5 inches. Well, if we go right between those, that means they must be shooting for exactly 14.375, because that is right in the middle of 14.25 and 14.5. That's less than or equal to 0.125 inches. So this is what it should look like as an absolute value inequality. And then we probably don't need to solve this like we did the first one. We would just know that the length of a football has to be greater than or equal to 14.25, but less than or equal to 14.5. And on the graph, we'd have 14.25, 14.5. Both would be acceptable, or we would accept anything between them, and it would look like that. Again, 2 points, and 1 point. Then we're going to move on to the graphing parts of our test. Number 9, x plus 3. Remember, it's negative b over m and then c to find the vertex. So I'm going to take negative 3 over 1, which is negative 3, and then negative 1. So my vertex is at the point negative 3, negative 1. It does open down because there's a negative sign in front of the absolute value, and if I multiply a and m together, it's a negative 1 times a positive 1. So my slopes are going to be both negative 1 and positive 1, which is going to look something like this. Number 10, very similar to number 11 or number 9, except a little bit more complicated. We have negative b, which is going to be positive 8 over m, which is 4. Well, that's 2, and then negative 3. So that means our vertex is going to be at 2, negative 3. Then if I multiply the a and the m together, 1/2 times 4 is 2, and it's a positive a value, so it's going to go up. And I'm going to go up 2 over 1, up 2 over 1. Half of the v is going to look like this, and then the other half of the v is going to look something like this, where the slopes are positive and negative 2. And those are worth 3 points apiece. And then on the back side, starting with number 11, it says write two linear equations that could be used to graph the following absolute value equations. And so for number 10, I'm going to first isolate the absolute value, which means I'm going to subtract 4 from both sides, and I'll have y minus 4 equals the absolute value of 2x minus 8. And then I'm going to write two separate equations. Either y minus 4 really does equal 2x minus 8, or y minus 4 will equal negative 2x plus 8. Then putting it in slope-intercept form, if I add 4 to both sides here, I'll have y equals 2x minus 4. That's one equation. Then the other equation would be if I add 4 to both sides to get this y by itself, I'd have y equals negative 2x plus 12 for my other equation. That's 2x plus 12. Negative 2x plus 12. So those are my two equations for number 11. And then number 12, to isolate this absolute value, I'd start by adding 12 to both sides. So I'd have y plus 12 is equal to negative 1/2 times the absolute value of 6x plus 3. But then I'm going to multiply both sides of the equation by negative 2. Multiplying by negative 2 is going to cancel out the negative 1/2. Negative 2 times negative 1/2 is just 1. So that means I'd have the absolute value of 6x plus 3 on the right-hand side of the equation. But then when I multiply this side by negative 2, I'd have negative 2y minus 24. You might be thinking, well, you can't have an absolute value equal a negative number, but if y is a really big negative number, then it's possible. Like if y is negative 20, this is actually going to be a positive value here. So I'm going to write two sides of this equation. One side would be that negative 2y minus 24 really does equal 6x plus 3. And the other equation is going to be that negative 2y minus 24 equals negative 6x minus 3. And so if I solve the first one first, when I get the y by itself, I would start by adding 24 to both sides. So negative 2y equals 6x plus 27. And then dividing everything by negative 2, I would have y equals 6 over negative 2 is negative 3x. And then 27 over negative 2 is a negative 13 and a half. And that would be one equation. Kind of wrote that sloppy, but hopefully you got that. Negative 3x minus 13 and a half. Then the other equation is, I would solve for y, again adding 24 to both sides. I would have negative 2y equals negative 6x plus 21. And then dividing by negative 2 to get y by itself, I'd have y equals negative 6 over negative 2 is positive 3x. And then 21 divided by negative 2 is negative 10 and a half. And that is the other equation. All right, and then the last two equations, the last two questions here. Number 13, it says graph the following inequalities. And so we'd first have to find the vertex. So this is going to be at positive 2, positive 4, which is here. It's going to be opening down because the a value is negative, and the slopes are going to be plus or minus 2. So I'm going to go down 2 over 1, down 2 over 1, and down 2, and to the left one, that's the one that has a slope of positive 2. But it's just less than that, which means it is going to be a dotted V that looks like this. And we're just going to shade everything that is less than that, which is all the values below that graph. These are worth 4 points apiece. And then the last equation, it's going to start off at negative 6 over 3, which is negative 2, negative 1. So negative 2, negative 1 is my vertex. And then this parabola, or this V, opens up because the a value is positive. But if I multiply the a times the m, 1/3 times 3 is 1. So it's going to have a slope of positive 1 and a slope of negative 1. It is a solid V because it's greater than or equal to that. And I'm going to shade everything above it because I want all the values of y that are greater than that. So this equation looks like that when we graph it. Again, you can rewind it and watch this as often as you want it, or watch each problem as many times as you need. But then also I will be able to answer some questions tomorrow when we get to class. Have a good